Hey, how you doing? Got a very cool bass in the mod cave this afternoon. This is a Yamaha BB1500A, and this particular instrument I think is from '91, but the model I think had been around for a year or two before that. Just like every other Yamaha guitar and bass I've ever seen, it's really well put together. The fretwork, the alignment of all the parts, the machining of the parts, the routes are super crisp. If you're getting into guitar building, then I'd say get down to your local guitar shop. You want to have a look through all the Yamahas and have a close look at all of the little details, because they're masters of getting those just right. The most interesting thing for me though with this bass is actually the preamp, or at least it would be if it was in the guitar. Unfortunately though, it's busted. So in this video, I'm going to see if I can mend it. Now, when the bass first came in, I had a look over the circuit board here, or circuit boards really, and there's a lot of stuff going on. At that stage I didn't have access to the schematic. The main reason it came in is because the blend pot needs replacing, and someone's kind of had a go at that and they've kind of damaged the tracks a bit, so I'm going to have to get a bit creative when I go to replace that. But yeah, there's a lot of interesting stuff going on here. For a start, there's a lot of omitted parts here, and even a whole IC and a bunch of parts here. Well, that's not uncommon for circuit boards of this era. I think they usually would create a circuit board that covered 2 or 3 different models, and they would populate it and wire it in different ways to suit different guitars and basses. The circuit actually has 3 op-amp ICs, so that means this preamp actually has 6 op-amps. And to give some kind of perspective on that, around about the same time as this was available in the late 80s, well, Stingray brought out their classic 3-band preamp, and it does what it needs to do just with 2 op-amps in one IC. So this has actually got 3 times as many op-amps. On this other board, it actually has 3 discrete FETs here, and at first I thought that might be some kind of individual buffering and for the blend control. That's what the TRB bass preamps of this era often did. The circuit boards combined have 4 trim pots, 2 conventional trim pots, and then 2 of these thumb wheel type pots. These are dual gain, these pots. But I think the most intriguing item on this circuit is this little guy here. It's the only surface mount part, and it's actually a 4000 series logic chip. And normally you would see these in control circuits and stuff. And to be honest, it's just about the last chip that you would expect to find in an onboard bass guitar preamp. There's a 3-way rotary switch. Honestly, there's a lot going on here. So as well as this blend pot that needs replacing and the damaged tracks, there is a few other things that need fixing. Obviously this interconnecting cable here needs replacing. These over time get so hard, this plastic has very little flexibility left in it, and these have all just broken through fatigue from handling, so I've got to replace that. It's a 6-way. And the other little bit of damage that I've discovered is that, or maybe it's on the other board, yeah, this trim pot here actually is loose. So this solder joint has been kind of pulled through, and I assume that's just because someone's pushed a screwdriver in here with a little bit too much force. You really have to be quite delicate with these little things. So I'm going to reflow that. So in circuit, this pot is around about 24 k ohms or just under. So if I just put my probe on the wiper, let's just see if it's going to sweep properly. Yeah, it seems okay. Let me try the other side. That looks fine, so I'll leave it in and I'll test it by ear when I get the bass back together. So I think the next thing I'm going to do is to remove this old cable and these old broken solder joints here. I could possibly trim this back and reuse it, but honestly I'm just going to replace it because there's every chance these are just as frayed or almost as frayed and about to break. So I'll get rid of this guy, and I think I can probably just pull the plastic off, and that way I can get to these individually, which is probably the safest bet for the circuit board. I've noticed that these holes have been enlarged, so I assume that at some stage another preamp has been installed in the base. And now I'm thinking the damage to this original preamp has occurred when it was actually put back in. Now, being an active circuit, we've got 50k pots, we've got a 10k pot here, and these days, if you wanted to use these type of pots in your builds and you were installing them in a rear route like this and they had to go through a good sort of 6 or 7 millimeters of timber, well, these days you can look around and you can often find pots in non-standard guitar pot type values with a long enough thread for that to work. But back in the 80s, obviously that wasn't the case, and what Yamaha have done so that they could use standard electronics pots here, they've actually routed a wide hole to about 2 millimeters, and then the rest of the hole, which goes through probably about 4 millimeters of timber, well, that would have originally been that 7 millimeters. And the idea with that is that the boss here on this on these pots will actually sit into that wide part of the hole, and then the timber will be wedged between the washer on the front side and then this, like I say, this boss. And that's really designed to take that kind of loading. That's why it's kind of built up this way. Unfortunately, with these holes widened out and then the pot and then these pots reinstalled in those holes, well, these bosses have actually been pulled right through those larger holes, and now the timber is being wedged between your washer on the front and these kind of mounting tabs here. And this pots just aren't designed to take a loading on the wider part of this upper housing, and certainly not on these mounting tabs. In fact, I've just squashed these back down again because clearly this top end has been pulled. In fact, I don't know if the camera can pick it up, but I can see that there's just a tiny bit of distortion here. This looks like this is sort of ovaled or curved slightly, so clearly this is being pulled up. Now, this is a problem for two reasons. Firstly, it can just damage the pot. Pots just aren't designed to take a loading like that. They could be damaged. But the other thing is that the clearance for the front end of the circuit board, or the front edge of the circuit board, is diminished because this is now sitting further down into these holes. As I mentioned, Yamaha are the sort of company that really dot their I's and cross their T's, and they know exactly how deep all of these holes are. They know exactly where every part is designed to sit, and I'm not sure if the camera can catch it, but just here there's a little shiny spot, and that is from this circuit board being installed, and that's actually the front edge of the board actually rubbing on this shielding paint, because clearly the pot's been dragged through this far, this way too far. And so with a pot like this, which is single gang, well, there's a little bit of slop in there and you can possibly get away with it, but with a dual gang pot, I reckon that's probably what's broken these tracks at the back here, or made these solder joints intermittent, because the pot's been sort of reefed forward slightly. So definitely something to look out for when you're installing pots. I think what I'm going to have to do is actually fill these 4 holes with resin. So I'm going to take them from the front and I'll mix up some resin, and then I'll just leave them overnight to set, and then I'll have to re-drill them in the morning. So this morning, with the resin set, I went ahead and re-drilled the holes. I got the correct spacing by actually measuring the circuit boards themselves. I also decided to give the whole route a little skim with my router. And that was just to reduce the top so that these pots will poke through and I can install them properly, and also to create a little bit of clearance for both of these circuit boards. Of course, that meant removing the nickel shielding paint that was in there, so I had to re-shield the cavity. I did that with copper tape, and I made a quick tech video on it with some of my top tips, so check it out. I also got my hands on a schematic diagram thanks to my old mate Barney, and it's really answered a few questions, that's for sure. So down here we've got our 2 pickups, and as you can see, they go directly into the balance pot. So what that means is our dual gang balance pot. So what that means is that Well, this is essentially a passive blend control because it's happening directly with the passive signal from the pickups prior to the input of the preamp, which is at this coupling cap here, C7. And the blend pot that they specify is a 500K A plus C or AC blend pot. And that means that one gang is an audio taper and the other gang is a reverse audio taper. And as luck would have it, I actually have one of those on hand. However, this is not a direct replacement for the one that was missing. It doesn't have PCB pins. It's got quite a long thread here. It doesn't have a 6mm solid shaft. So I'm going to have to get a bit creative when I install this. Looking at the schematic, we've got our bass and treble controls. Interestingly, the bass control actually has a gyrator, which is a circuit around this op amp, and that'll give us a peak response instead of a shelving response. And I think it'll be interesting to find out what the center frequency of that is. Moving on from our buffer and our treble and bass control, well, that's where the circuit gets really interesting. We actually have 3 audio paths coming off the input stages. This guy across here is our bypass, and then we've got 2 kind of custom mid filters, and that's what these trim pots are for on this secondary board here, to adjust these kind of set and forget filters, and then you can switch between bypass and then your 2 different mid settings. These FETs here, that's what this symbol here is. Well, that's these 3 FETs that I was a bit confused with. They're actually switching FETs, and they simply switch the audio path one at a time through each of those 3 positions. And this is very similar to what the classic Boss pedals have as their bypass. And the gates of these FETs are controlled by our hex inverter, or 3 of the inverters from our hex inverter, which of course is then in turn actually controlled by the switch itself. So the switch is not really connected to the audio at all, and we have this really quite elaborate way of switching between those 3 settings. It does seem like overkill to me, but this will give us a dead silent switching. There'll be no little pops or anything like that. It'll switch silently from one filter to the other. And then this is our volume control, which is of course buffered by our output stage, which has a variable gain, which is what this little guy is for. That's our trim pot as the gain control on the output stage. So here's our A and C 500K blend pot. I would assume the A taper or audio taper is on the top wafer and the C or reverse audio taper is the bottom wafer, but it doesn't hurt to double check. So I've got the controls set to the middle notch, and well, there's our total resistance for the upper wafer, which is a little bit less than 500K, to be honest. It's 470K, and the lower wafer is about 478K ohms, but it's still close enough to 500K. With the control in the middle, with the A taper on top, you'll find there'll be a small resistance of something around 15% of the total, about 75K ohms, between the wiper and the anti-clockwise lug, and then between the wiper and the clockwise lug you'll have the rest of the resistance. In this case, yeah, about 400K ohms or just a bit less. And then the C taper, of course, will be the opposite. So you'll have your small resistance round to the clockwise side between the wiper and the clockwise lug, and then you'll have your large resistance around here. And it's important to work out which is which, because when you wire this as a blend pot, you've got your 2 pickups, hot wires connected to the wipers, and then these 2 outer lugs will be joined diagonally, and one pair will go to earth and the other pair, in this case, will go to the input of the preamp. And that means that the 2 pickup hot wires are actually being summed together via the small resistances, or this 15% or 18% resistance that's left in the pot with the control in the middle. So it's important to make sure it's orientated correctly. So that means that I am going to connect this guy, top left and bottom right, to hot, and the other 2 diagonal lugs to earth. As for which pickup goes to which center, well, you can work it out if you think that you'd like to wire this in a conventional way, where you roll it clockwise to get the neck pickup and anti-clockwise to get the bridge pickup. Well, obviously that means as you roll it clockwise, this wiper will be connected to the hot in the lower right, and this guy will be connected to earth. So as you wire it, as you roll it clockwise, then this will be the neck pickup and this will be the bridge pickup. To be honest, with this preamp, it's kind of a moot point because the pickups are connected to the board via these little clip connectors, and if it was orientated the wrong way, I could always just swap them around. Now, for installing this new blend pot, well, the easiest way would just be to wire it up with just loose wires, and then connect those to wherever they need to go on this circuit board, and then just install this particular board with one pot like that. Normally that would be okay. The trouble is this obviously has a short thread and there's no room for me to put like a shape-proof washer under here. The anti-rotation lug has been removed as well, so this would almost certainly, without those things, just become loose, especially as a volume control. Someone will dime this and this will flick around and it's very likely to sort of short on the other board or something like that. So I really do think it needs to be installed with two things to mount it. So I am going to connect this pot to the board directly. And you might think, well, you can just run wires out of here and then just put them into the old spots that the old PCB pins went. But the problem with that is that because well, that'll throw the pot forward slightly, and then on top of that, with this long thread, well, these knobs won't line up at all. So you'll end up with basically a pot like that, and you'll have one knob sticking right up tall like that, which is not ideal at all. So, and I can't really mod this knob to make it work. I don't think that would work with the way it's designed. So ideally, I could install this sort of back further a bit, and then our knobs will line up. But I think, on balance, the easier thing would actually be to install this with the lugs pointing up. Maybe I'll even just put a blob of hot glue under it or something to hold it while I solder those up. But I think I'm going to have to remove some of these parts for clearance. This is an earth wire, and I can just remove that and pick it up from somewhere else. I'll be able to get an earth wire from somewhere else on the circuit board. This is our input coupling cap. It says 104, which is 100 nanofarads, and that will go directly to the diagonal lugs that are the hot side. And I reckon I can't solder to this because it's actually one of the pads that's damaged. You can see it's just hanging there. So I think I'm going to remove this. I've got plenty of 100 nanofarad caps. I think I'll remove this and then run a cap, sort of like a flying cap, a point-to-point from the good side of the circuit board of this cap up to the pot that way. The two inputs I can run, if I remove these two little guys, they look like resistors, but they're actually just 0 ohm resistors or jumpers actually. So I can actually remove them, and they're both connected to the hot side of these snap connectors. So I can remove them and then use the other unused solder eyelets. Alright, I've got my blend pot all ready to wire into the circuit. I've connected the opposite outer lugs to one another with like a crisscross arrangement with some hookup wire and some heat shrink. One of those pairs I've got my input coupling cap, and that can go into the board, and the other pair I've just got a wire there which will go down to earth. I relocated the earth wire because I'm going to use that lug for that earth, and it's now coming out the back from another spot. I've got my hot melt glue gun ready to go. I've also wound on a couple of washers and a nut to this pot just to make sure that the amount of thread is the same as all of the other pots, and that way the knobs will line up properly. And on top of all that, I've made a little jig so I can get the spacing right for when I put that drop of hot glue on there. try and hold that in place and eyeball it so it's aligned while that glue cools down. So I decided to replace the foam under the pickups. Someone had kind of cut it off anyway. The glue from the original foam came up with a heat gun, and then I just replaced it with what I normally use, and that is closed cell neoprene. Works really well. The pickups themselves, well, they're a bit of a mystery, to be honest, and that's because they're potted in epoxy. The schematic seems to indicate that they're humbuckers. There's 2 coils in each pickup, and they seem pretty quiet when they're soloed, so I assume that's right. The magnetic arrangement, though, inside the pickup looks to be a straight sort of bar right across the whole pickup. Plus, they have a very high resistance at, I think, 15.5 k ohms, so I assume they're stacked coil humbuckers. But either way, they sound great and they work really well. I did have to re-solder one of the pickup wires, and that's because, well, at some stage someone had cut it and then re-soldered it, but not done such a great job of it. I'm not sure why they had to cut it in the first place. Perhaps the clip connector had broken at some stage, I don't know. But they'd actually sort of melted through the inner insulation when they'd soldered the shielding on the outside. And my top tip for that is just to use a heatsink clip on the shield. They work really well and they'll take the heat away, and you're much less likely to damage that inner insulation when you solder shielded cable that way. So now I could test the preamp on the bench, and the first time I fired it up, instead of a battery, I use one of my bench supplies, and that's so that I can set a current limit just as a precaution in case there's any other damage or anything that I've missed. After all, the preamp did come in disassembled and I'd never actually plugged it in before. I normally just use my phone as a sound source, so I can plug it in to my bench amp and just kind of audition all of the filters and the various features on the preamp. The only thing I'd say is if you're going to do that, you want to turn the volume down on your phone or your iPod or whatever to maybe halfway, because of course its output's going to be quite a bit hotter than a typical guitar pickup. As a bit of fun, I connected up my old USB scope so I could do some bode plots on the preamp. Turns out the bass control has a center frequency of 50 Hz, fairly low. Treble control, as I thought, is a shelving filter, and it sort of boosts all the way up to sort of 10 kilohertz or thereabouts. The first EQ, I think, is essentially supposed to be like a slap contour. It has a big old notch that you can sweep around between 270 Hz and up to 2.8 kilohertz, so right through that mid-range. But it's also got a little bit of boost either side of that notch. So I guess with that, they're trying to get that kind of Marcus Miller kind of scooped Sadowski Aggie 1 kind of boost only style preamp sound. EQ2 is what you'd call typically a semi-parametric or a sweep mid control, and it works through the lower mids. You can sweep it from 120 Hz up to 900 Hz, and then you can adjust its cut and boost with the little blue trim pot there with a screwdriver. The last thing on the preamp to test was the boost control, and fully anti-clockwise, it actually has a slight cut of about 2 dB, and then you fully cranked, you get a boost of I think 5.5 dB. Fitting the preamp was pretty much straightforward after all the work I'd done to make sure it was going to fit, and then really I just had to solder a couple of earth wires, one from the bridge and one from the circuit itself. Just soldered that up to that copper shielding tape. It was pretty simple. I did actually have to replace 3 of the knobs. So the bass came with 2 large knobs and then 3 small knobs, and one of the small knobs was missing. And the closest thing I could find was at my local electronics shop, and it's a very similar design, but not quite the same, so I ended up replacing the 3 small ones. There was a little bit of a fitment issue with them, and how the skirt of the knob actually goes over the nuts of the pots and that 3-way switch, but we worked that out. I posted a quick tech video on it the other day, so check that out. And the bass is done. It all works just as it should and sounds pretty good, although unfortunately the bass is currently sporting flat wound strings, so I can't really demonstrate like the sort of treble potential of the bass, because there kind of is none, but the blend pot really works nice and smoothly. You just sort of morph from the sound of the bridge pickup into the sound of the neck pickup. It's quite cool. And the filters, there's that. Just sounds like a bass boost when you've got no treble coming from your strings, but I assure you it is a mid contour. And then your second one, I've got it set around about 180 Hertz with a slight boost. Sort of thickens up the lower mids. Anyway, that's another preamp done. I hope you enjoyed the video. It was a bit of a mission, but we got there in the end. If you did enjoy the video, please like and subscribe. Also hit the bell. It really is a huge help for small channels like myself, especially when you're like me and you have a day job and you don't necessarily have the time to make a video every week. Hitting the bell just ensures that you're going to see all my content. So thanks for watching. I'll see you next time.